Yes, data science is changing. I'm going to do my best to keep it as little technical as possible, and I often tend to speak fast, so please feel free to stop me if you don't understand something. But basically the point is data science is changing, and why should you care? I guess unless you live under a rock, you would know that ChatGPT is the fastest growing product in history. It took them only 5 days to reach over 1 million users. And so that has gotten a lot of people to start thinking about what's going to happen to data science as a field and where is it going. There is a problem though. 91% of AI fails in the first 6 months of being deployed, which is a huge problem for businesses who are trying to deploy these models into production. And it can have disastrous consequences. I'm not sure if you guys heard of the Zillow case, but they systematically overpriced 7,000 houses by $300 million. And basically when that news broke, they lost $32 billion in market cap. And they fired 1,000 people and completely left the house buying and pricing market. And so when models fail, people lose a lot of money. Data scientists tend to agree with this. A paper published in Nature around 6 months ago now, I think, actually did a systematic study that showed that 91% of models degrade by around 20% performance within the first 6 months of being deployed. And this is basically caused by models acting in the real world. So essentially, you have to know that these models, they're just like humans. They're acting on data that's coming from the real world, and the real world is always changing. And so as the real world changes, your model can get worse over time. And just like a human would have to update his beliefs about the world, eventually do the models. And so is data science as a career dying? This is actually from Katie Nuggets like a few days ago, where people are really concerned about what's going to happen to data science in the future because it's a very complex field. LLMs are coming in very, very fast. And so data scientists kind of have to update what they're doing and how they're spending their time. And I argue that data science is not dying. It's just changing. So basically, I've been screaming this for the past 4 years or so as we've been working on NannyML, that data science is changing. Machine learning engineers and data scientists have to focus on the real world implications of their machine learning models, get them into production, and make sure that they're adding business impact. And so what are we going to do about it? The first thing that we're going to do is understand why we should care. I mentioned a little bit about why we should care and why this is important for data scientists, but also for the people investing into machine learning and AI. You're going to learn about what post-deployment data science is. So what do you as a data scientist would need to do to manage your models in the real world, and how do you ensure that your models keep adding business value? And finally, just quickly about how you could get started today. So why should you listen to me? I'm just a crazy guy that sometimes has a mustache. Now I have an afro. It changes. Well, for the past 4 years or so, I've been working on NannyML, and firstly, other data scientists do. So we've been creating a lot of content and built a big community of the most senior data scientists in the world, from all over Europe and the US. We have a LinkedIn community of around 40,000 senior data scientists and lead data scientists. Our content gets around 500,000 monthly impressions across all of our platforms. And our blog gets around 4,000 reads a month. And of course, just because other people listen to me doesn't mean you should listen to me as well. There's other reasons. NannyML is one of the leading open source libraries for post-deployment data science. There's over 3,000 monthly active instances of NannyML open source. We have over 300,000 downloads and over 10 papers citing NannyML's algorithms. And to just give an example of what these look like, this is one of my favorite papers where a team actually used NannyML to ensure that a model they built for detecting the spread of West Nile virus in Europe was robust during different climate change scenarios. And they could basically actually use our algorithms to validate, okay, if there's a 2% increase in temperature or a 3% increase in temperature, how well are we at actually predicting the spread of West Nile in Europe? And one of the other papers I like to cite is a team published a paper in the IEE, so in the Journal of Electrical Engineering, where they actually use NannyML to help calibrate cheap sensors. This actually was a use case that really, really surprised us because it wasn't an intended use case of NannyML. and where they could get a cheap sensor to perform just as good as a sensor that cost 100 times more than the ones that they were using. So why should you actually care about this? Well, the only value that you can add as a data scientist is once your models enter the real world and you're using them on real world applications. If your models are not in production, if businesses are not using your models, you're not really going to be adding any value. You're just basically a research team. And I'm sure if you're a data scientist, you've heard this all the time. Models in a notebook add zero value. They have limited organizational impact. You have a lot of executives, especially now with LLMs coming out, wondering about why they even have a data science team and what ROI you're actually bringing to the organization. And basically, you'll end up with very limited career growth. And so that's why as a data scientist, you should care about your models getting into production, how well they're performing, and the business impact that you're bringing. And of course, as maybe an investor, you should care because failing AI costs billions of dollars to the organizations, not only monetarily, also reputationally. Companies can fail, entire teams and departments are fired, and billions of dollars are lost. Yeah, you're okay. And so as a data scientist, your career really depends on it. Because if you don't get models into production and if you're not driving business value, basically sooner or later, your team is gonna end up getting fired. Okay, so now we know a little bit about why we should care about this as a data scientist and as an investor. So I'm gonna explain a little bit about what post-deployment data science is and what does it actually mean. And before I jump into that, I would like to just mention like what is deployment. We use that word a lot. Kristen is a friend of mine, and she tweets a lot about data science and machine learning. And she explains it as a model being deployed where it's doing inference, so it's making predictions automatically, either on batch jobs or via an API. She said whether the organization it was built for is using it is another question. For me, that's not a good enough definition. I would say that a model is not really in production unless your team is using the predictions it's making and the output that your model is doing. And so what is everything post-deployment? What does that actually mean? The first thing is model performance monitoring. So it's understanding how your AI or how your models are performing and the business impact that it's driving. And this is super important because, again, models can fail. And if they fail, it will cost you a lot of money. And so you need to know how your models are performing. The second is communication with the business teams and understanding what their strategies are and being able to maximize the impact of your machine learning models. This is an interesting one. So designing and running real world pilots. So the thing about machine learning or AI is that you can't deploy it all at once, especially in very operationally heavy organizations. So if you think of a manufacturing company or any company that's manufacturing something and they're deploying like a predictive maintenance model, you can't just deploy it to all the factories in the world all at once. It doesn't work like that. There's workflows that have to change. People have to do different things. And also you don't know whether the model will really have a positive ROI. And so normally you'll deploy to a single location and then see how the model performs over a period of time. And then if you know that it's going to have positive ROI, you're going to scale out to all your other locations. And then that leads to being able to scale your models across your organization, across the use cases that you have. And then finally, continuous experimentation. That's very important because getting into production is just day one. The story that I always give people is like, you know, mainframes, there was a time maybe 50 years ago when banks were building their mainframes. And I'm sure when they were building them, they were like, oh yeah, this is going to be a lot of work. And then we're done. And now 50 years later, mainframes are still the main technology used in the back end of most banks, at least in Europe. And so the life of a model and the life of a use case, most of the time will be spent in production. And so you have to be able to continuously experiment and to understand how can you maximize the ROI that your models are bringing. And some data scientists might be asking, isn't this just MLOps with extra steps? I would say no, because MLOps is heavily focused on engineering. And it's really about like, okay, how do we take a machine learning model, scale it on a bunch of data, and make sure that it's actually running and making predictions? It's not very much concerned with the model performance and the business impact that a model is bringing. I'm going to give a quick example using demand forecasting because I always like to kind of make it a little bit more concrete. And And so basically demand forecasting is a model that retailers like Walmart use to predict how much product they have to buy. So basically how much demand they're going to have. And more companies are starting to use machine learning for this. And to put real numbers on it, the biggest case I saw is I spoke to a head of data science at a retailer that I can't name. It's not Walmart. And their demand forecasting system was generating $500 million a year in revenue. So the impact of these models can be massive. It can mean sometimes that 1% performance increase or decrease can cost up to $6 million a year, or give you $6 million a year. They're also very complex use cases. So sometimes you have thousands of models, and there's a lot of debate in the data science world whether you should have thousands of models. But the problem in demand forecasting is that every product has its own loss function. So you can be optimizing for different things. Because, for example, ice cream, you might have a lot of freezer space, and so it's okay to have too much ice cream, and you never want to run out so that your sales don't get impacted of it. But for example, fruits and vegetables, you can't ever have too much of it because they rot and they go bad. And so you're actually optimizing for different things across different products and product categories, which makes it very complex from a data science and a machine learning perspective. And it's, of course, critical to all supermarkets. So basically, as a data scientist, you really need to be obsessed about the performance of your machine learning model. This is a slide I don't have to spend too much time on, but one thing I do want to highlight is it's actually very important for a data scientist to understand your company's strategy and what it's actually trying to achieve in a coming quarter. Because you can think, oh yeah, let me just build a machine learning model that will increase our revenue. But if your company's strategy for this quarter is to decrease costs, your model's actually not going to get into production and nobody's going to care about it. And it's a lot easier for you as a data scientist to understand what your company strategy is than for the executives and business leaders in your company to understand the data science and decide what use cases have to be prioritized for this quarter. So it's just very important for you as a data scientist to understand what's going on and to work with all the stakeholders in your organization where your use cases are going to touch so that your models actually get into production and they're actually bringing business value. And then, of course, managing the pilots and scaling of it, monitoring the performance of your models, having a strategy in place for retraining or updating your models as the world is changing. And finally, the experimentation that I talked about earlier. And so some of the highest impact post-deployment workflows you can do is actually the designing and running of real-world pilots and the monitoring of the performance of your models. And I just want to highlight why the pilot part is so important. And I actually think it's going to be something that will spread to all of data science and machine learning. Because we essentially backtest our machine learning models. So we only know how well they're performing on historical data. But for example, when you actually put it out in the real world, maybe you can't change the business workflows to actually fit what you're doing. And so in demand forecasting, yeah, you can have the best demand forecasting model in the world, but if the employees in the supermarkets don't put the products on the shelf, it actually doesn't matter. If the company is not willing to update its supply chain to deliver products more often than necessary, you can, no matter how good your model is, it's not going to matter. And then also the cost of changing all these workflows and changing all of these things is super expensive. And so you have to do it in a small scale at first. And these pilots can be quite hard from a few perspectives. I already mentioned what a pilot is, so I don't have to talk about it too much. But one of the most important things is having a very well-defined success criteria. Like, okay, we're going to run a pilot in one location on X number of products for, say, 8 weeks. What does it mean for this to be successful? How much ROI does the business have to get? How much increase in sales do we need to get to be able to scale this model across all of our locations? And that's a very hard question to answer from a data science perspective, but also often from a business perspective. And this is one of the hardest things you can do post-deployment. We've been spending a lot of time on it recently, helping companies scale the machine learning from one use case, from one location or one area across all the places that use case can be used. One of the big problems is that data scientists often have no authority in changing workflows and in messing with these kind of things. Other stakeholders might not follow the new workflows, so even if people agree, again, in the supermarket, if the products don't get to a shelf, doesn't matter how well you predicted the demand, your model's not going to work. Which is kind of crazy. There's a lot of room for error. You're dealing with the real world, and everybody has a plan until they get punched in the face. Machine learning models are not different. The second it touches anything in the real world, it will get punched in the face, and it will probably not work as well as you expect it to. And this is one of the hardest parts, is that pilots actually have to be scientifically sound. And so you actually have to, with quite a little bit of data, be certain of the ROI that your model is bringing. And there's some pretty hard real world constraints. So to leave demand forecasting for a second, if you talk about manufacturing and you're doing a predictive maintenance model, it's not only about reducing the downtime of your machines, but also the quality of the product that the machines are producing. And sometimes you might reduce downtime, but then you're going to destroy your products. And so it's a very hard trade-off. And so doing the pilots can actually be very, very difficult. And they have to be very well designed. And the reason why it's hard is the science is not always as hard as we think. But to tell somebody in a factory that, oh, you have to do this because of science is very hard. And sometimes they just refuse. It's like just really, really complex people issues as well. And then the second part is on the monitoring the performance of a machine learning model. I think this is also something that's a bit technical, so I don't have to dive too. Oh yeah, I want to say a quick word from our sponsors, which is NannyML. So we're building software that help data scientists do all of this. The first side of NannyMLs are open source. So we have a set of algorithms that allow data scientists to estimate the performance of their models without having access to ground truth. Basically, we just tell data scientists how their models are performing, which is super hard, but it's quite important. And then the second side of NannyML is our cloud platform. So the open source is just the set of algorithms that we researched and developed at NannyML. And our cloud product is basically 30% better algorithms. And it's a few minutes to monitor all of your machine learning models with all of the engineering, orchestration handled. You just have to point NannyML to where your where your data is, and to do a little bit of configuration for your machine learning models. And it's available on all the cloud marketplaces. It's also free to get started. So yeah, if you're a data scientist, feel free to try it out to make sure that you know how your models are performing. So I put that here because our main focus at NannyML is actually performance monitoring. And the first part of it is actually just answering that question. Are our models performing well, or are they not? And if they are not performing well, you then have to understand why is the performance changing. So that's a root cause analysis. So you have to understand what data actually changed. And by what data, it also means what changed in the real world, because data is just information about the real world. You just have to understand what changed that might have caused my model to degrade in performance. And sometimes, by the way, it has nothing to do with data. Like imagine if you're a supermarket chain and you built this great demand forecasting model, and then a competitor opened up stores next to all of your locations. Like you're not gonna see that in your data, and you might not be able to predict demand based on what you knew before when you built that model. And so then you'll see that model performance completely collapses. And then the last thing is issue resolution. So if you know that your model performance has changed, you then have to fix it. Basically, you have to update your use case, and that can mean retraining your model. That can mean refactoring your model. Refactoring, it's like not the set term for it, but I don't know what to call it yet. It's basically sometimes the changes are so big that you have to go do EDA again. You have to do new feature engineering. You have to really dig deep and essentially build a new model. And then, of course, the last thing, which is the most painful and the most expensive, is changing up and downstream processes, either with the data collection or the business workflows, because you realize that the workflows that they're following make it that your model don't work, which is like, yeah, we don't want to go there. And hopefully if you do your job well when you're setting up your use case, you don't have to do that. Yeah, and so that's just kind of a view of the whole monitoring flow from performance monitoring all the way to the issue resolution. Cool. So now you understand why you should care. You understand what post-deployment data science is. How do you get started as a data scientist? Funny enough, you get started before your model before you even do pre-deployment data science. You get started before you write your single line of code. And I think it's super important that data scientists understand that you have to build a business case for every use case that you build with all of the stakeholders involved. You have to understand what are the quarterly goals of your company. You have to understand what are the goals of all the teams that are involved. So if you think of a demand forecasting use case, you have to understand the purchasing team, the transportation team, even the teams that are in your stores. You have to understand what their goals are, and you have to make sure that your model actually aligns with their goals, or nobody's ever going to listen to you. Yeah, that's what I just said. So, and you also have to understand the cost and revenue structures of your business, because it can be that once you put that all together, once you realize what workflows you have to change, and what it actually costs to deploy your model in production, whatever value gain that you got with your model is actually not there. And it's not a use case that's worth building. And it's actually up to you as a data scientist to figure that out. and to figure it out before you even start building your model. And then you also have to estimate the model impact of your use cases. And then the next thing is that I know I said that notebooks, the models in the notebook don't add any value, but they're very good for prototyping. So I would suggest, if you do have models in production as a data scientist, to just build a post-deployment Jupyter notebook that you can just run and assess how your models are performing, especially if your ground truth is delayed. Yeah, and you can just get started with NannyML. We have very, very comprehensive documentation, also explaining all the algorithms, how they work, and a lot of other topics on post-deployment data science. And so basically, yeah, data science is changing. You as a data scientist should care, and you should definitely start fixing it and working towards it today. That's it. Thank you.